Hi class, in this recording we'll be focusing on PhysioEx exercise number 11, activity number 3. And as we're looking at this activity, we're going to be focusing on the amount of hemoglobin in the blood. To determine the amount of hemoglobin in the blood, a device that shines light through the blood is used. To review and refresh, hemoglobin is a pigment in the blood that is made of globular proteins and heme subunits. And these hemoglobins will transport oxygen within the red blood cell. The heme subunit needs to have an iron atom in the middle for the oxygen to bind to it. When we have a hemoglobin bound to an oxygen, we call it oxyhemoglobin, and it has a very bright red color. To quantify the amount of hemoglobin in the blood, we typically are going to use a device known as a Hemoglobin Ometer. And that device will take green light and shine it through the hemolyzed blood sample, and then based on the amount of green light that gets through the sample, you can quantify the amount of hemoglobin in that individual's blood. For baseline levels of hemoglobin, a healthy male typically will have 13 to 18 grams of hemoglobin per milliliter of blood, and a healthy female will typically have 12 to 18 grams of hemoglobin per 100 milliliters of blood. Individuals that have polycythemia or congestive heart failure, chronic obstructive pulmonary disease are typically going to have an increase in hemoglobin levels. Individuals that live in high altitudes will also have that increase in hemoglobin levels. Individuals that have anemia, lupus, kidney disease, liver disease, hypothyroidism, or bleed a lot will typically have decreased hemoglobin concentrations in their blood. As you worked through the experiment, this was your setup. You were to take a blood chamber dispenser or blood chamber, put it on the tray, take a drop of blood from the sample, put it in the tray, stir it up with a stick, and then dump it into the hemoglobin meter, and then record the intensity of the light. After working through your experiment, you were given a data table to fill in and some post-lab questions. Post-lab question number 1 asked, as mentioned in the introduction to this activity, hemoglobin levels increase for people living at, excuse me, that's not the post-lab question. Let me get to those post-lab questions for you, which I have over here. So, question number 1. A male that has polycythemia, sample number 4, is deficient in hemoglobin. Why? So let's look at our samples here. So sample number 4 is the male with polycythemia. So this individual right here had an elevated hematocrit. So this individual has more than the average amount of red blood cells, polycythemia. However, when we look at the amount of hemoglobin per milliliter of blood, this individual has slightly elevated hemoglobin concentration. So as we look at that, we have 20 grams of hemoglobin per that's a typo here. This should be milligrams of hemoglobin, not mg. Milligrams of hemoglobin per 100 milliliters of blood. So this individual that has polycythemia, this male with polycythemia, has a ratio of of hematocrit to hemoglobin of 3 to 1, which is the same as the ratio for the healthy male, shown right here. So, is the male with polycythemia deficient in hemoglobin? The answer is no. If anything, that individual is elevated. Let's go back to the results. Even though this individual has the same ratio as the healthy male, when we look at the hemoglobin concentrations per 100 milliliters of blood, we see that 20 milligrams of hemoglobin is higher than 16 milligrams of hemoglobin per 100 milliliters of blood. So in other words, if somebody has polycythemia and everything else is kept the same, they're probably going to have elevated red blood cell concentrations and elevated hemoglobin concentrations within their blood. Next question. How do the hemoglobin levels for the female Olympic athlete compare with the hemoglobin levels for healthy females? As we look at the female Olympic athlete, she has a hemoglobin level of 22 milligrams per 100 milliliters of blood, whereas a healthy female has a hemoglobin concentration of 14 milligrams per 100 milliliters of blood. So in this instance, the female Olympic athlete has a higher concentration of hemoglobin in her blood. Is either person deficient in hemoglobin? The answer is no. The healthy female, by definition, is not deficient in hemoglobin. The female Olympic athlete, though, has elevated hemoglobin. Question number 3. List conditions in which hemoglobin levels would be expected to decrease and provide reasons for the change when possible. In these situations where you would expect hemoglobin to decrease, let's go back to our pre-lab information. So as we look at the pre-lab information, we would expect individuals that have anemia, hypothyroidism, cirrhosis of liver. This last sentence right here gives us a list of conditions where the hemoglobin levels would decrease. And in all of these situations, these individuals either don't have enough supplies to make the hemoglobin, so if they don't have enough iron, for example, if they have iron deficient anemia, or they don't have the ability to make the needed things. So for instance, the liver makes many blood proteins. The kidneys also are going to help regulate blood production. So these individuals are also going to have decreased hemoglobin concentrations. If they bleed a lot, if they have severe hemorrhaging, well, obviously they'll also have decreased hemoglobin concentrations. So those are some common examples of individuals that would have decreased hemoglobin, and we talked through why they would have that decreased hemoglobin. Question number 5. Describe the ratio of hematocrit to hemoglobin for a healthy male and healthy female. The normal ratio of hematocrit, 2 grams of hemoglobin, is approximately 3 to 1. Discuss any differences between these individuals. So as we look at these individuals, the healthy male has that 3 to 1. Sample number 1 is the healthy male. The healthy female has a ratio of 3.14 to 1. So this healthy female is going to have a slightly higher ratio of hematocrit to hemoglobin concentration, which is a nice way of saying that the female per red blood cell has slightly reduced hemoglobin concentrations per red blood cell. Or another way to rephrase this is that an individual red blood cell in this female, for sample number 2, does not have the oxygen carrying capacity of an individual red blood cell for a male in this example, because the male has a lower ratio. And I know we weren't asked to talk about sample number 3, but I feel like it's worth mentioning right now. Sample number 3 is that individual with iron deficient anemia. So this individual has a very low concentration of hemoglobin. They have a reduced ability preferentially to make hemoglobin. Their ability, though, to make red blood cells is not that impaired. So when we look at this, 40 divided by 8 gives us a 5 to 1 ratio of PVC to hemoglobin. So the iron deficient female is going to have the highest ratio. And per red blood cell of all of the samples that we looked at, samples 1 through 5, the iron deficient female is going to have the lowest concentration of hemoglobin per red blood cell. Or to phrase it differently, per red blood cell, this individual would be able to, has the lowest oxygen carrying capacity due to the lack of iron that corresponds to the lack of hemoglobin. Question number 6. Describe the ratio of hematocrit to hemoglobin for a female with iron deficient anemia and the female Olympic athlete. So when we look at our female Olympic athlete, because she is working out constantly and exposing herself to situations where she has oxygen deprivation when she's having her workouts, she has a very low ratio. Whereas the female with iron deficient anemia has an impaired ability to make hemoglobin will have a very high ratio. So the female Olympic athlete, out of all the samples shown, samples 1 through 5, has the highest concentration of hemoglobin per red blood cell. And that female with iron deficient anemia has the lowest concentration of hemoglobin per red blood cell. And that's all we have for this discussion. If you have any questions or comments, please feel free to post them in the class discussion board. And as always, happy studies.